Hi everyone, we're Group 2 and we are building a system called the Infant Vitals Monitor. And I'm Sam Romano. This is Anastasia Pavlovic. This is Zach Childers. This is Clayton Winter. And this is Jeff Spangler. And I guess we'll get started, and Ann's going to present the background and problem statement.
Basically, this sort of smart vitals monitor system basically all originated from the conventional audio monitoring systems, which is like the baby monitor that just provides you an audio so you can hear if your baby's crying in another room. Essentially, these things sort of increased in popularity. SIDS was kind of a big thing. They got really, really popular in the late 80s. Now that there's the mandate that your babies should sleep on their back, SIDS has decreased enormously, so that's really good. But basically, we want to provide something that is residentially available. So they have these smart vitals monitors in the NICU and places like that in hospitals, but they really only have residentially available systems like this Angel Care monitor. And what it is it's two platens that fit under the mattress of the baby's bed, and basically it's just movement detection. So what happens is if they have a setting so that if there's no motion detected for 20 seconds, that it'll sound an alarm. And essentially, respiration is just detected in the system as some sort of movement, and it'll ring the alarm if there's no movement. The problem with this system and the way that it can be approved upon is that it doesn't store any data. So say your baby had problems dating back for several months where it stopped breathing. Sleep apnea is very, very common in children. So this system doesn't store any data. So what happens is, maybe your baby stopped breathing several times, but it was for less than 20 seconds. You would never know that. And conversely, doctors would never know that if you brought them. So one thing that we thought was, it'd be really neat if these kind of storage systems had storage so that they could be provided to the doctor, or the parent could look back and view past data. So we sort of tried to expand on this system and others for our research. Our problem statement, mainly to help parents and caregivers monitor a child's well-being, more smart than the regular audio system. We want to design a vitals monitoring system that is available in a more residential setting so that many different types of families could potentially use the system in their home. Also, it'll be pertinent to new and experienced parents, and available in a decent price range so that this isn't like a couple $1,000s, like nobody would ever buy it. Our prototype will probably be a little bit more expensive than the price that it should be marketed. But I was kind of thinking, if I were to buy this system, I would definitely buy it if it was like under $500, especially if a lot of people thought that it really worked well. So I think that's kind of a moderate range. So those are our goals. Requirements. We decided that our system will monitor 3 vital signs: pulse, respiration, and temperature. We also sort of hummed and hawed about, the Angel Care system has the platens. What would be the best way to detect more than one of these types of signals and very accurately? And we came up with the idea of a garment that the child could wear. Obviously, we'll want it to be waterproof so that it can't be soiled and it can be wiped down. Also, so that the hardware of the system and the sensors can be removed and the garment can really be like hosed down type of thing if you wanted it to. Sort of the goal of the system obviously is to sound an alarm if abnormalities are detected during use. Now, the cool thing about this is that if we do the 3 different signals, it's going to be detecting a much more broad variety of problems. So, say that their pulse goes out the roof. Well, the Angel Care monitor would probably never be able to detect that unless they started, rolling around uncontrollably. And again, that wouldn't sound the alarm, so it doesn't matter anyway. Similarly, temperature is kind of a neat thing because depending on the way that the user can control the settings, if the baby has like a slight temperature, obviously, you know, no, they're not going to die, but you're aware of that again. So it's also a preventative thing, not just like it's an emergency, my baby's going to die. So, and that use is neat too, because it just sort of expands our user variety. These are the tables of our marketing requirements and engineering requirements. They're pretty similar, and we also mapped them together in our design documents. Basically, I won't go through all of these because I've talked about a lot of them already, but you know, like 3, we want the garment to be comfortable so that an infant could wear it, not just when they're sleeping, but you know, kind of laying down. We want to minimize false alarms. Another key point that I haven't really talked about, we ideally want the system to operate using wireless technology, because I think that will make it really, really slick for users. Also, system will store approximately the past 48 hours of use. So say you only use this, you know, on your child at night, that's expanding. It's not just like the last 2 days. Also, we want the alarm to be visual and auditory, so sort of some kind of bright blinking light, as well as a loud audio alarm. And what else is important here? Oh, also, this last one, number 13, we want the system to be able to be changed so that, say, your child has a normal heart rate that's higher, you can alter that so that it's not just standard run-of-the-mill, because you know certain children with you know different vital signs, it would be going off all the time if you couldn't ever change it. So that's a pretty important factor as well.
All right. So again, our system architecture for this will consist of 2 main components, pretty much. There'll be the garment that the child actually wears, and the personal computer where the user receives the data. And this just gives you like an overview of what we're going over to like help you understand the architecture of the system. So, all right, the garment that actually houses the sensor and the other hardware and wireless transmitter for the data to be sent to the computer. And the probes from the sensors will connect to the child without any wires, or just mostly just like contact. And the sensor data, the data that the sensors pick up is small, very small, like millivolt range. So it will need to be actually amplified and filtered so that you can interface it to a microcontroller and also send it wirelessly to the computer. And like I said, to do that we'll use one-pass filters and analog to digital converters. And there'll be software on the microcontroller itself, like telling the system when to receive data, when to amplify, when all the stages will be take care of the software. And it's just like an architecture of that. You've got the child here, the 3 sensors, like you said, we're doing the heartbeat, the respiratory, and also the temperature. And those will go into the signal conditioning, where they'll be filtered, cleaned up, and then it'll go to the analog to digital converter, which will amplify the signal and change it from the analog signal to the digital. And then it'll be interfaced to the microcontroller, which will then transmit the data. And for the other component, the personal computer, this will receive all the vital sign information from the child, and it'll also be where the user transmits commands, like it wants to view the data.